The next three are special purpose materials.
Where am I? Okay,
Soda ash, sodium chloride.
So soda ash will be a big player in our soda firing class. But we add this to glazes
and we use as a fruit.
all as a group called Chino glazes.
Oh, the Chinos. Okay.
And if you've ever used the Chino glazes, when you before you stir them up, there's a layer of what looks like mangrove
Oil.
swamp water on top, dark brown water.
Uh-huh.
Well, that coloration's from the soda ash.
Oh.
Soda ash is a material I put in my hot tub once a week to balance the alkalinity. It goes into swimming pools also.
Put that in our pool.
It's really important when you have those circulation-based hot water situations that you manage the alkalinity within a range so that you don't corrode your pipes, or if it's the other direction, you don't pack the inside of the pipes with minerals.
So the soda ash that you buy to put in your pool, or
pH plus.
it's we would be able to just use that in our club.
That's what I buy for the studio.
It's more reasonable probably to do it that way.
Yeah, because we always seem to run out, and I can go to Osh and get some.
Oh, so you just buy that at like someplace like Osh, and it's basically
Home
used
Depot.
for in
Pools.
like pools.
Yeah.
It comes in a liquid form, right?
No.
Or is
No,
it
it's
powder,
always-
or the powder form that comes in a big bag?
It's water soluble.
Okay.
You have to
melts
keep
in
it
water.
sealed. It will suck water out of the air. So you want to keep it sealed,
Okay.
but you
That
want to
would
use
be
it.
put in swimming pools too, right? Soda ash?
Yeah.
That's what it is.
Now-
Besides spas, yeah.
One of the most interesting characteristics to soda ash is that melting temperature, 1652.
Right.
So it's lower than our glazes.
Normal glass.
Because it's water soluble, when you dip your piece into the glaze and pull it out, the water is absorbed by the bisqueware. The ground up rocks remain at the surface. But the water cannot evaporate from the bisque water from within the form. It has to migrate to the surface where it evaporates. Well, it's coming to the surface with the dissolved soda ash in it. And so as the water evaporates, the soda ash precipitates out on the surface of your glaze. Now you have a material on the surface which melts at a lower temperature than the glaze below that layer. And very often with our Chino glazes, this creates a situation where we put the piece into body reduction. Remember at Cone 08 last week, we were talking about altering the atmosphere? Suddenly we got all this carbon, and then the soda ash fuses and it traps the carbon below the surface of the soda ash, between the soda ash and the other glaze, which melts at a higher temperature. So you get this black deposit. It's very unpredictable in location, and that phenomenon is called carbon trapping.
Is that something you want to do?
No.
You don't? Okay.
Well, depends on what you like.
Sometimes I've seen it at the bottom of the bowl. Yeah.
So carbon trapping is a characteristic that art potters think is pretty cool, and other people dislike.
I
love the
I
Chinos,
show
though.
that it's used as a deflocculant for clay slips.
Also, we add it to casting slip.
It's for casting slip, not the same slip that you're using to put on your.
No, for casting
Okay,
slip.
casting slip.
Clay, naturally, when we add it to water, gets wet, and then it flocculates.
It separates.
Flocculates, it clumps.
Oh.
If we want to cast something in a plaster mold, we want the clay to remain smooth and evenly distributed in the liquid mix. So we add soda ash and sodium silicate as deflocculants to not let the clay clump.
Keeps it in suspension.
Right.
Which ones would do that?
Soda ash and sodium silicate, usually in combination. Sodium chloride,
Used in salt glazing only.
Salt
That's all
firing
I
and
got.
vapor glazing and
Yeah.
savers. And it's
well, it's interesting
table
because salt glazing developed in Europe and Germany, came to Pennsylvania with immigrants, and we're all familiar with those big old storage crocks that usually have cobalt blue, maybe 3 or 5 gallons in there, a little floral relief. and then some dark glaze on the inside, usually Albany slip clay. And the offshoot of this is that it became very popular again in the late 70s as studio potters began to experiment with it, not to make those old crocks and jugs and butter churns, but as an expression of art pottery making. And it creates hydrochloric acid gas or mist that comes out of the kiln, which is not particularly good for living beings. Very aggressive on lung tissue. And that eventually led to people looking for a source of sodium that was no longer bringing along the chlorine. And that led to the soda firing that we're working on this semester. But here's a Portuguese wine bottle with salt glaze.
Yeah. It's got that characteristic.
And
Not soda, but salt.
it's, right, salt
It's
glaze.
fired upside down?
No.
No.
And the glaze is usually described as being orange peel, citrus
Yeah.
skin in
That's
character.
orange peel.
So, a lot of folks have moved away from salt glazing because of the toxicity of the gases.
But now, I have it listed as table salt,
It is.
and this is table salt without iodine in it.
Probably don't care.
Really?
Sea salt.
Just throw it in the kiln and the ions dissociate and the chlorine goes off as a gas with water vapor.
I
And
would think sea salt would have other minerals in
it does,
with
but not enough, probably. You know, I mean, that's another one of those, your research assignment for the next 3 years is to try 1,000 different sources of salt and show to us how they vary.
Himalayan salt's the best. It's peak.
For people, not for farming.
So, the last of the glass modifiers is another clay, bentonite. Bentonite is formed by the decomposition of volcanic ash. It has the highest level of expansion and therefore contraction of all clays from wet to dry. It is so nasty, and it covers a good portion of Wyoming, that ranchers on dirt roads, if it rains, they park the truck and walk home.
What does it do?
It turns the road into gumbo. It just
Oh,
slip and
really?
slide, no control, and
Wow.
yeah,
Yeah.
We went through Wyoming. We went through
yeah.
Wyoming.
But it hadn't just rained, and you're on the
No,
interstate.
it wasn't just rain, but it was getting ready to. We had some of that.
It was bad enough
Wow.
when I lived in
And
Northridge, we had it on dirt
It's hard to
streets
put
with
into
adobe.
water. I remember that.
Yes, it's
Non-soluble.
problematic to try to add it to water,
Mm-hmm.
but it can be made wet with time and patience. It's put into wine sometimes to fine wine and beers to fine out the yeast particles.
Oh, nice.
Sometimes used to repair old wooden hot tubs and fill the cracks.
Oh,
Wow.
For us, it's most important. We use it in concentrations
promotes
never more than 1.5% in the glaze recipe to help keep the other materials in suspension,
Yeah.
keep them from settling rock hard at the bottom of the bucket.
to prevent settling.
The last three items on page 3 are the opacifiers. What does it mean for something to serve as an opacifier?
It makes it non-transparent.
It moves from one end of the spectrum being transparent, you can see through it, to the other end of the spectrum being opaque, you can't see through it. And then there are lots of steps along the way, varying degrees of opacity, semi-transparency, translucence. And the most efficient opacifier is tin oxide.
Ah. But at very high temperatures, it will start to become transparent.
Defined very high.
Well, I saw it here as at cone 10, but I don't know.
Yeah,
I don't know what that,
not my
I
experience.
don't know what that is in Fahrenheit.
Cause see, it shows here unchanged at 2192, which I don't know, I have to go look at
I
it.
just saw that
That's fire
in one of
So,
the places.
Here's
I
how it
saw
works. It's a powder.
Yeah.
It's a little speck of white that doesn't melt. It doesn't dissolve into the glass. So it floats in the glass. So the higher the concentration of little white specks, the more opaque the glass becomes.
Right.
Now, the flip side of tin oxide that's problematic is it's very expensive.
Oh, okay.
There was a time when it was the same price as filet mignon. I don't know which is higher now.
Yeah.
And so we can pretty well exclude zinc oxide because it's mostly an opacifier at lower temperatures, and it's just nasty to deal with, and it absorbs water and it clumps, and it's no fun. So there are a whole collection of zirconium silicate synthetic opacifiers, synthetic in the sense that they have to be fabricated by industry. One of those, I mean, there's Ultrox, Opax, Superpax, Zircopax. They're all the same thing. We use Zircopax in the studio to serve as our opacifier of choice. Except that, I'm going to tell you a story about Stanley and Alex.
Oh, Stanley and Alex. Remember them?
No.
These are two friends who were both studio potters at the same time that I was. And Stanley was not as successful financially, but he was very creative. And so he rented kiln space from Alex. And Alex could afford, in a glaze called tan yellow matte, to use tin oxide as an opacifier. And Stanley couldn't afford the tin, so he used Zircopax. And I happened to be there the day that we observed this phenomena, but Alex was unloading the kiln, and they each had the same glaze except with a different opacifier in it. And Alex's version of the glaze was yellow, orange, rich in coloration, and Stan's piece was kind of muted and tan colored, except on the side next to Alex's piece, where
The beauty stuff.
he had the color that Alex had.
Yeah.
So the tin vaporized enough during the firing to affect the glaze of the adjacent piece.
Wow.
And that's when we realized that even though tin was really expensive, it was probably really valuable to keep in the glaze recipe, but it didn't take very much of it to cause the desired effect. So then we took all this, so if the glaze said 6% tin oxide, then we would drop that to 2%
And then add the Zircopax.
tin oxide and make up the difference in Zircopax,
Yeah.
and that seemed to have worked out really well.
Cheaper blend. More affordable blend of making.
Yeah, this is sort of like how do you get the best of Starbucks without paying for it all? Yes.
Just a Starbucks and you can go to 7-Eleven, put the same stuff in.
So, the concept of opacifiers is pretty straightforward.
Yeah.
But the fact that the tin is so reactive with iron made it desirable to maintain some of that in the recipe. Oh, we're doing great. We're doing great. I'm looking at page 4. I'm looking at the colorants.
Uh-oh.
Oh, this is the fun one.
Yeah.
Are you gonna hide?
Yeah, I forgot.
Red iron oxide is the most frequently used colorant. It's very common in nature. It is used to create a whole variety of colors. In matte glazes, it will be prone to yellows to browns, tan to brown in range. In transparent glazes, it creates a whole array, depending on its concentration, of colors from pale green to olive, darker green to black. In a glaze with bone ash in it, it can give us a rich array of brown to red coloration. So here is a clear glaze on B-mix. Here is the same glaze with 1% red iron oxide added to it, giving the classic Chinese pale green known as celadon. Now we're at 2%. 3%.
Wow.
4%. You have to line them all up to really see the incremental changes.
Wow. It's like putting two different glazes on there, the color.
Well, technically, they are two different glazes
Yeah.
because it's the same base glaze but different concentrations of iron.
Yeah.
And that's actually mixed into the glaze?
Yes,
Okay.
5%. And after that, it goes increasingly, darker
Wow, it almost looks like.
until when we get to the end of it, we have what we call gloss brown black at 11%.
Wow.
Same base glaze, but increments of red iron oxide. Now, I don't have all the other possible variations. And while we're talking about these oxides, it's important to recognize that you don't always use them by themselves. You may use them in combinations with others.
So you put together a base glaze, say 5-gallon tub of base glaze, and then you take out of that and in bottles or whatever, you will start adding oxides or different colorants and then go from there then.
The only problem with that approach, Mary Ellen, is it's hard to know how much glaze material and how much water you have in that sample that you've extracted. And if you want repeatability, then you want to compare the oxide addition to the raw materials that are making the glaze. So typically, you could mix up 10,000 grams of a base glaze, but stir it to the point where you can assume it's well homogenized. And then you would extract the dry material, probably 1,000 grams, and add the oxide to it. Then
while
add
it's
water.
dry, okay.
Right,
I see.
otherwise,
But you could still mix up in the base without the water. You
Right.
could mix up a tub of the
yeah,
Glaze material.
glaze
you could take all these
materials
things,
then.
put them in a tightly sealed container, roll it around on the floor for a couple hours, and probably put some other stuff in there to help
Like
agitate
take the
it.
barrel and
Yeah, yeah. But if you tried it with the water technique, then you're never sure what your
Okay.
concentration is.
okay, but that still it saves you a lot of hassle though if you can mix up a. It's like in baking if you mix up a base stuff
Yeah,
you can
yeah.
build all your cookies off of one base
Yeah.
dough
Yeah, I
formulation.
appreciate the desire for efficiency. It's very clear. Red iron oxide can be put on the surface of greenware below the glaze. It can be mixed into the glaze. It can be applied onto the surface of the unfired glaze. And most of that's true of all these oxides. But you have many ways to approach those. If you're painting 100% concentrated red iron oxide, you really never know how much is reacting with the clay and the glaze. So typically what I do is I mix my iron oxide into a liquid slip.
Okay.
And in a couple of weeks, I'll show you that, and we'll do that.
Now on that blue bowl that you
Right.
this here, this you painted the red oxide on before.
This is all of the darkness you see here was the iron oxide in slip,
Oh, in slip. Okay.
right, applied to the surface of the piece on the rim. Right.
Okay.
Rutile, titanium dioxide that's impure, tends to give us a whole array of warm, earthy tones, yellow gold to orange into brown in matte glazes. But if it's mixed with a glossy glaze that has barium carbonate in it, we get this bizarre titanium blue. And so we have a whole family of glazes where we're counting on the titanium or the rutile to create this highly reactive glaze, which depends to a significant amount on the clay body to which it's applied in terms of its final color.
Can you get that to eventually go to a turquoise as opposed to a titanium blue? No.
Not with
Okay.
titanium.
Well,
If
then
you
I
want
won't
turquoise,
bother
you
to
have
buy that.
you have to use cobalt in the soda feldspar glaze.
Okay.
Cobalt carbonate is at its core the source of all things blue.
Yeah.
It is my most disdained glaze.
How come there's a glaze over there that says Bob's Wonder Blue?
That glaze is
You were
this
here
one.
last week.
That glaze was given to me by Alex. I asked him after I started teaching if I could introduce the glaze here, and he said, sure, no trouble. And it was called Slate Blue. And I introduced it to class, and a week later it was renamed Bob's Wonder Blue by the students because of my great fondness for blue glazes. But this is not bad. It's the cobalt, those horrifyingly vibrant blue glazes that sell really well.
Blue.
They
Sell really well.
Oh, yeah, men love blue.
Yeah, they do. My
I know.
my grandkids love the blue cobalt blue.
So the source of the name is a tongue-in-cheek gotcha.
See, this is
And
about
you're
the kind of
reminded
blue I
every
would-
Every single time. And you will be reminded more of that before the day is over.
Sure.
So cobalt is a very concentrated colorant, typically used from 0.25% up to maximum of 3%. It's so strong that if somebody picks up a piece with crystal blue glaze on it and then picks up your white mat and doesn't wipe their fingers, you get blue spots. That's such a small amount to be transferred from a fingertip that way. But and I'm not talking about a wet glaze. I'm talking about dry powder glaze.
Right.
Yeah.
So cobalt's insoluble? I mean, doesn't mix with water or?
Well, none of these are soluble,
Okay.
which we don't want soluble materials in glazes almost ever.
Okay.
They cause all kinds of problems. Solubility of your material means it goes into the liquid form, it goes into the bisqueware. You don't want to give away your colors into the core of your bisqueware.
Okay.
Yeah, so these are all
Stays on top.
You
insoluble.
want them to
Stay in the
melt
mix.
together.
Yeah.
Okay.
So I have that an increasing temperature intensifies the color on the cobalt. Have you?
Well, at cone
Noticed
10,
that.
it's pretty intense.
Okay. Yes, it's a colorant. You could use it in anything.
Oh,
from
yeah. Yeah,
Low fire to, okay.
Yeah.
But it wouldn't be as intense. And
Right.
like, well, you'd have to add more of the colorant to make
Yeah.
the intensity.
right, right.
Okay.
But it's used to make strong blacks.
It's one of the mixture of ingredients that can be used to make black.
Yeah.
Yeah.
Along with Nichols.
And in the presence of soda feldspar based glazes, that's where you can get purples to turquoise, other glaze colors than you get with potash.
So you
That-
add that with what?
Soda based feldspar,
Soda.
soda feldspar.
Soda feldspar.
It's still a strong colorant, but it's amazing. If you took the same glaze recipes and only changed the feldspar and had the same amount of cobalt, you'd be shocked at how the colors vary.
Ooh.
Now, I said that silica was one of the silicon dioxide, pure silicon, one of the highest melting things, but this next one is the highest melting one, chrome oxide.
Yeah.
And it generally, in low fire, you can get red with it, but in high fire, it's always green. And it's a disdainfully uniform green. You can't see the forest or the trees.
But mine says if they add a little tin, it can produce pink.
That's in low fire.
Oh.
Yeah, it produces a pink flush and will become
Soften it with a
unstable.
little iron or magnesium.
Oh.
So, I never use it by itself, but it can be mixed with other glaze ingredients to get some interesting coloration. But it tends, because of that high refractory nature and its tendency toward high uniformity, you don't want to ever use too much of it, or you'll just get this blasé.
OD green.
Not terribly dissimilar to Brian's shirt color in the shadows. By contrast, we mix iron and chromium to create iron chromate, and that's a warm, dark brown to gray colorant.
Gray brown.
And we mixed this glaze in the studio on a number of occasions. I came back and went to work using iron chromate on a glaze when I returned from a trip to Utah, east of Capitol Reef. The Manco Shale, this incredible, crisp, eroded gray, lunar landscape, kinds of landscape. Fascinating. Manganese dioxide melts at a very low temperature relative to these other metals. And by itself, you can paint it on a piece and it will form a deep purple glass. And right after you take it out of the kiln, it will flake off.
Man, you got me all excited.
Yeah, I was like, ooh, I'm gonna try that.
Then
Then
you
he says,
paint
take it
until it
off.
flakes off.
Well, it shivers. It's that behavior where it's not shrinking as much as the
So
clay
it won't
body.
even leave a residue in there where it
No,
bit
it
into
flakes the surface. It takes the clay
pulls the
off,
clay
pulls it
in
off.
there.
Oh,
So what do you
the
have
clay
to do?
off.
Yeah.
Oh, wow.
You can't blend it with anything to make it stay.
Well, you can do it whatever you want. Now, some of these things I'm telling you are the direct result of in my studio career early on. I took every single material I had in the studio and fired it separately, just to see what I would have to work with.
Well, that's a good idea though. I mean,
Yeah, well, now I showed you the fusion test. But that was, we didn't do it thoroughly, but these give you some clues about the materials.
How much they melt and
But I add red iron oxide, cobalt carbonate, and manganese dioxide together to make a black that I can add to slip, or I can add to painted decoration on glazes. So, it's got its
what were
place.
those colors? Manganese?
Manganese dioxide.
Then the red iron?
Red iron oxide, cobalt carbonate. So it's 2 parts red iron, 2 parts cobalt carbonate, 1 part manganese dioxide. Maybe a little bit of ball clay to make its brush or spread easier. By itself, it's a black dry mat if it's not too thick. Not a glaze. Copper carbonate, another of the very popular additions. And depending on the base glaze, can give you a whole array of colors from greens to turquoises or red.
Beats copper red.
It says more than 5% will give a dark or metallic surface.
Yes, it begins very quickly to saturate the glaze. So we have a glaze called Val's Rutile Green. It uses copper carbonate in it. And if it puddles in the bottom of the bowl, you'll end up with a black metallic scum on the surface of the glaze. Now, a side note. Copper reds
And he's having more fun than we are.
Copper reds are only available to us in high fire reduction. They were developed in China during the Song Dynasty. They are sometimes difficult to arrive at.
It's a nice one.
And while I was at my workshop at the Anderson Ranch this summer, Matt Long was talking about some experimentation he did during his graduate studies in which he made draw rings. So he made clay loops, glazed them all with the same glaze, put them in the kiln, and then periodically reach in and pull it out of the kiln and study it for how it appeared at that point in the firing, on the way up to temperature, at temperature, on the way cooling down. And what he discovered is that there's something really important. This is counterintuitive because the red is a byproduct of the copper going into reduction and getting closer to the metal. And you'd think that in the glaze, once it came out of the kiln, it would be done. You got what you got. Oftentimes not really appealing. So I came home and I glazed this bowl with the intention of doing this experiment he told me about. And it came out so beautiful, I didn't have the heart to break it. But here's one that was in the studio.
Oh, yeah.
So this is a piece
Oh,
I
yeah.
found in the studio, and this is very familiar to anyone who's tried copper reds. And what Matt said is he took a piece and broke it and put the other half into a cone 04 oxidation disc firing.
Okay.
And it came out spectacular red.
So he double fired it?
So it was like it
So-
needed a little more.
Oomph, and can't explain the oomph yet. So I did that.
It works.
It's got a
Oh, you
hole
did,
in it.
oh,
How pretty.
you did it to half of it?
Yeah,
Oh, you cut it in half, you broke.
broke it and I glued it
That's why
back
it's got a hole in the bottom
Be
then, okay.
darn. And you went into 04
together. Oxidation.
in oxidation. Huh.
Oxidation, electric kiln. Okay.
And it really brought out the beautiful color in it. My word.
So it just needed additional chemical reaction with the heat for
Well,
whatever
the
reason.
heat and the oxidation, but see, in my mind, it's like, wait a minute, the glass is already melted, it's
Yeah.
already cold, it's
Yeah.
sealed,
Yeah.
so
Nothing
What's
more to be
happening?
done.
there should be no penetration
Right.
of the gaseous
But,
into the glass.
You're wrong.
So
Wow.
right now, it's just like everybody's going to bring in their old copper red pieces.
I was just gonna say, I have a that I have, and it's got a bottom to it, and the top of the big bowl is square, and it looks like that one half. Now, when if I bisque some stuff, can I put that bowl inside with all my biscuing stuff?
They don't
And
fuse.
Yeah.
Wouldn't it fuse?
wouldn't it fuse?
Well, no,
No,
don't.
I won't touch it with anything.
Yeah, don't touch
Still
it. There.
do.
No.
Yeah, just have it.
Oh, I'm gonna try.
Only are you allowed to do this if you promise to bring it in and show me afterwards.
Oh, you wanna see before and after?
Take a picture of it before.
Yeah.
Because I'll bring it in and show you before, but then I just bisque, so it'll be a
So
while.
this is cone 10,
to get
Right.
in here.
and it just separated all over the place.
Right.
Or you didn't,
But the inside looks really beautiful on it.
it's just
Yeah,
a
it is.
The
little
inside's
dark.
always pretty. The outside
That's
is
because
what.
all, you can see where the glaze tried to migrate down.
That
So this is
is
A new
such a
change in
lush.
an absolute counterintuitive thing.
Wow.
All I can say is this is what happened, and I can't explain it, but
Oh,
it did.
now this thing was all looked
Now
like
try
this
to
too?
replicate it.
Really?
Yes.
Oh.
You're a little kid in a candy
Oh my, that
store.
bowl of mine was, so too. I love the red.
Wow, it just brought it out.
Oh, yes. Oh, wait till I tell Solvar.
Like it redid carbon trapping a little bit, huh, or something.
Well, there's no carbon in oxidation
Well,
firing.
yeah,
That
okay,
is
that's true.
amazing.
It's like you added another glaze to the top of
You know what
it.
he did?
Yeah,
See how the reds turn out?
I showed it last week.
Oh, my God.
She knew that.
Well, you've had some experience.
The last of the common coloring oxides, nickel oxide,
Nickel.
quite refractory also. It will give more of a tendency toward brown than green, but a real earthy green brown.
Depending on what fluxes you use.
Yeah, everything is dependent on what the other
Fluxes.
glaze ingredients are. However, it has one characteristic that used to drive Stephen Foner, who was the lab assistant before
I
Mike.
remember him.
Is this glaze, when it's fired and comes out of the kiln, has the tactile quality of a chalkboard.
There's a what?
Talk about it.
Tactile surface of a chalkboard.
Oh.
And it used to drive Steve absolutely, he just hated picking that up. And then somebody would take their finger and
So it was really matte finish then.
Oh,
Yeah.
the
Oh,
darn.
Well, it says it'll darken colors obtained from other oxides.
So
Or
keep in mind
modified.
that in most color blends, we use all these different ones in various degrees.
Wow.
And you're going to be doing a lot of testing and experimenting. So here's a handout that I acquired some years ago from Long Beach
City College.
City College.
I went there. Lost my pen.
And what I'd like you to start with is on page 1 to look at the list of names under potash feldspar. Kingman, Buckingham, Clinchfield, Custer, Keystone, Yankee, Maine, Plastic Vitrox, Donia A3, Oxford, Godfrey, Elbrook, Moco H. If you have a glaze recipe that calls for potash feldspar, any of these can be used interchangeably. But in reality, today, the only commonly available potash feldspar is Custer.
Now, why do you have an asterisk behind Custer and Plastic Vitrox?
Well, since I didn't write that, I'll have to look and see
Oh,
if
you
we can.
don't know.
Oh, in
studio
this case,
stock.
studio
Okay, I
stock.
see. I was looking for the
Yeah.
explanation on here. That's right, you didn't.
So in this particular, in Long Beach City College. Now for soda feldspars, you notice the first one is nepheline cyanide, as per our discussion earlier.
Yeah.
Kona C6, loose bar, and so on down. When you see Kona F4, further down the list,
Okay.
they've changed the name and they've dropped the Kona. So it's just now sold as F4. That's our studio soda feldspar.
Is this from
We
the
have nepheline cyanide and we have F4,
volcanic stuff in Hawaii or something?
probably. But there shouldn't be any feldspar mines in Hawaii, but
Yeah, really.
No Kona feldspars.
Oh, they just got.
Cornwall stone, we have some around. That's from England. It's very expensive feldspar to use because the rocks are the same cheap rocks. They're just very far away.
Importing, yeah.
Shipping.
Shipping. Okay. Everything else in there is just extensions of what we've talked about and some leading ways to go into what we're doing. At the bottom of the page 1 is Albany slip clay, just in case it's no longer commercially available. It's mined from the banks of the Albany River. There's that brown electrical insulators, but we have a local one that has almost the identical formulation called Cuyama slip clay.
Will you show us how to use that one? Oh, that's just the glaze, huh?
Well, the raw
Oh, we can use it as a
material is
slip, too.
Cuyama river clay.
Cuyama. We'll use it as a glaze, huh?
How you spell it?
Cuyame.
The rest is adds to your experience, of which you are gaining more by the week.
My head's full. I wonder what I have to knock out.
Oh, just, yeah.
Okay, I want to take a 7-minute break and then we will continue with Bob's Wonder Blade. That would be most likely referred to as a shop recipe.
Shop recipe?
Yeah, it's all the materials are the same, the percentage is the same, but if somebody was mixing up this glaze and they were going to put it in a 10-gallon bucket, this might be the recipe. So, what I would like you to do for starters is consider that the metallic oxides, the colorants, will from this point forward be described as additives. Things that we add to the glaze to alter it in the form of color. Also in that list would be opacifiers. Or in the case of using bentonite to keep the glaze in suspension, it would be an additive. So what I'd like you to do is take a look at that recipe and put an A beside each ingredient that you think is an additive.
Oh.
Everyone but the China Bloody.
Ooh, you're looking up.
No, I was verifying what I was doing.
Just
And so the copper carbonate, the cobalt carbonate, and the rutile are the metals that we add to provide color in this glaze. That's this glaze right here. Bob pointed. That means that the other ingredients are part of the glaze formula.
Okay.
And so put a G next to those ingredients.
So the other ones were A's?
So the additives,
Yeah.
copper, cobalt, and rutile,
And then the G's what?
the ones that make up the
Glaze.
base glaze.
And the next one?
So those are going to be china clay, whiting, and potash feldspar.
You can make a glaze out of those three.
That's it?
No, I meant without those
Sure.
additives.
Yeah, it's still a glaze.
Okay, it just doesn't have any color necessarily to it.
Right, that's
Okay.
correct. So on page 2 of that handout, this is the standard glaze spreadsheet that you'll be working with for the rest of the semester. And you always start with this at the top. Name of the glaze, the temperature at which it's fired, the atmosphere, and the source. And fill those in.
The atmosphere meaning that it's oxidation or reduction?
Correct. The firing and atmosphere are kind of redundant, so don't worry about having two different calls for that. Brian, will you help Linda?
So we put an A next to coloring.
Now, this is why the source of the glaze recipe will prove to be so important to you.
Base glaze. And then he wants. So we
Bob's
put the
friend.
name,
John,
temperature,
yeah, you can say it's from Alex, you can say it's from Bob.
Okay.
what kind of fire it is.
John is one of my students. John is looking through old copies of Ceramics Monthly. He sees a glaze that says luscious green. He mixes up the glaze and he test fires it, and it doesn't come out anything near luscious green. It comes out puke brown.
Choose for base fire.
And he brings it to me and says, I don't understand. And I said, where did the glaze recipe come from? And he says, oh, and he had written it down. It was from a 1978 Ceramics Monthly, page 38. And we pulled out that copy of Ceramics Monthly and went back and checked, and sure enough, it was named Luscious Green, but it was intended for use in assault firing.
That's different.
And he latched onto that luscious green name and
So,
Scott,
he ended
so
that.
firing here,
And atmosphere are redundant, so don't worry.
oh, okay.
Don't worry.
That's, you said that, I'm sorry. I'm sorry.
So, in this spreadsheet, what we're going to do is take this batch recipe at 16,000 grams and convert it to a unity-based recipe or a percentage recipe. And you're going to do this in the following way. First of all, you're not going to put any numbers down on this page. You're going to list the glaze ingredients in that column, one per space, in descending order. So perhaps at the bottom of your cover page, you list your primary glaze ingredients. So potash feldspar is the most, so that would be the first one. No numbers, please. What's next?
Whiting.
Really?
No.
No.
China clay.
Kaylin. Yeah.
Now, what is china clay a name for?
Callan.
Kaylin.
Kaolin.
So you can write either one and you'll accept it.
I'll be happy if you can remember that it's all the same. Kaolin, China clay, EPK. And the third one?
Whiting.
Okay, again, no numbers. So, going back to your cover sheet, write down those 3 ingredients and the number of grams called for each of them.
Put down there. Oh.
In the unity column, the grams in the unity,
On your
No
cover,
numbers.
on your
On your-
cover page.
on the cover
Okay,
page.
On her page now.
All right, well, wait. I was, my idea is if you wait, it will all become clear.
Yes.
That look familiar now?
Okay, should we write that in the unit?
No.
Oh,
Yeah, okay, there's.
I
there's
will,
where
I
we're-
will tell you
Okay.
step by step what to do.
But that's what these numbers are, they're grams.
These are grams to create a glazed batch of 16,560 grams.
Right.
But it also, the additives are in there. Right now, ignore the additives. So, let's add up, what do these ingredients add up to in this batch recipe?
Okay. So this is. Four. 2, 6.
16,000, yeah.
We agree,
Okay.
we agree. Okay.
Even.
Now, we want this recipe to add up to 100.
Okay.
So you drop a few zeros,
And here's how we do that.
divide it by.
Divide each of the ingredient values by the total.
I'll let you do
Since
that.
you're dividing these by more than the amount that you're listed, you're gonna end up
The
with a
decimal.
decimal result, a fraction less than 1.
What's the first one?
So we want to go to a batch of 100,
Right,
and we just want the proportion here. Got
right.
it,
Or the percentage,
yeah.
right.
What?
0.615.
For feldspar,
Yeah.
what is it?
0.615. Yeah, 0.615.
Okay, for kaolin?
61.5% of the glaze.
Got the calculator.
All right, I have a calculator. Science nerd.
Only
Have to have
everybody down here's
calculator.
using their calculator, so.
Okay.
Anyone
I
else
got
with a
mine on my
calculator?
phone.
0.204.
Yeah, you do the calculator, make sure it's right.
thank you.
0.204.
Okay, so that's
So,
0.204.
So then we're gonna go
20.4%.
Yeah, 20.4%. And
0.181.
0.181.
181.
Yeah.
Now, this
They
is
have us graph
very
it out
much
on
the
this
long
pie chart.
version of this.
Yeah.
Mary Ellen's already looked at that and converted it to a percentage. But technically, the next step is to multiply each of these by 100. Those of you who are comfortable mathematically will know that you can also just move the decimal point 2 spots to the right. But the result is you're going to end up with 61.5, 20.4, and 18.1. And it's critical to your long-term well-being and mathematic accuracy that you add the column up.
10,
Verify, huh?
10, yep, it's 100.
100.
Then,
Teaching
you
how.
now know what the percentage of each of these is in this glaze recipe, and these are the numbers you write in the unity column.
Ah, okay, now the ball drops. Yes,
Kidding.
okay.
And so this is the actual glaze.
Right, this is,
So,
you may
this is
visit a potter
100
and they're kind enough to share their glaze recipe. And they, they may have it written as a shop recipe and they mix it up in 10,000 gram batches. And that's what they give you. And what do you do with that information? Well, you can convert it now. And if you do all of your glazes on 100 base, it makes it very easy to compare them with each other. So that somebody's shining bright, vibrant white and our glossy opaque white, and you think you've got two different glazes and you compare them and find out same glaze or very similar. And in glaze world, glaze titles like 131A don't serve us in a very descriptive sense, so we come up with names that are a little closer to the glaze. Gloss brown black, tan yellow matte.
Frost white.
But frost white is perfect because it looks just like opaque white. I mean,
Yeah.
Just to go over the math again, when you divide that, you ended up with a percentage, correct?
you end up with a decimal fraction,
A fraction,
and
and
you
then,
multiply that by 100, and that gives you a whole number with a decimal fraction.
okay, and is that a percentage?
That's a
there?
And
percentage.
because it all adds up to 100,
It's 100%.
then it also is transferable in language to being percentages.
And a whole is always one is a whole, so, you know.
Don't get
then
too
we-
complicated
oh,
on me,
okay.
you're gonna lose me.
Okay, so at this point, we now have a base glaze of 3 ingredients. Feldspar, a flux, and a glue.
Okay.
To go back to where we started today. This one doesn't call for silicate. Potash feldspar, Custer feldspar, is a perfect cone tin glaze. But we have no way to use it. We're going to stick it onto something. We need a glue. The glue is going to raise the melting point of the feldspar. We have to bring in a flux. That's the dance of glazing. Now, everybody comfortable with this? By the way, your third page shows you how to do all this.
Yeah, I was looking at that.
That's because you didn't tell us.
But I'd rather.
So,
walk
because,
through this.
doing it once isn't gonna get there.
Yeah.
We'll start here next week when we're starting to mix glaze next week.
When they call
Good.
for feldspar, you automatically think it's potash.
The default feldspar, if that's all it says is feldspar, is gonna be potash
Okay.
feldspar, and in this studio, that's
Okay.
Custer.
Okay.
Yes, great, a point I meant to make earlier, thank you.
The custard queen.
Because I kept saying potash.
Bob, I got a new name for her, the custard queen.
Custard feldspar queen.
Wow, the Custer Queen. Okay, now, you have 3 additives. Will somebody read them to me in descending order?
Rutile?
Rutile.
Rutile.
Rutile,
Rutile.
sorry, 320.
Copper carbonate, 160.
What's the, it's 160?
160.
And cobalt.
Cobalt carbonate, 80. So
Now, do you see that this is a foreign language?
Didn't say what you.
It says exactly the same thing you told me.
Right, cobalt.
Well, as long as you understand.
Cuprous, copper.
Yeah.
Copper
CO is
carbonate.
cobalt.
Cobalt. I don't, cobaltus, who knows? Cobalt carbonate. And these are the colorants, and so I want you to list them, no numbers please, in the additive section of that recipe sheet.
Okay, now do we need to use the periodic table notation there, or can we use the name?
These are extremely common. No, there had nothing to do with the periodic table. These are being used 80 grams, 160, 320.
No, I didn't mean that. I meant, do
Miss,
you want
can
us to
she
use
use the name Rutiel and?
the scientific form?
No, I have no need for you to.
Okay,
You can write these out full length. You can initiate.
okay,
you know,
that's just a shorthand for you.
Well,
You-
actually,
okay.
the reason I'm doing that is very specific. As you look at other recipes, you're going to see various forms of notation for different materials.
Yeah.
And you need to become familiar with some of these. These are the most common ones. I don't care anything about lithium and some of the other stuff we talked about, but
Okay, so when the oxide, when the oxygen has a 3 below it, it makes it a carbonate, and if it has a
2 is an oxide.
2, it's an oxide?
well, it depends. I mean, you're not going to find CO2
I was gonna say,
as an ingredient because that's a gas and it's
okay,
gone.
but I'm just saying that
Yeah.
that's our way of
This is the
designating
this is-
that it's a carbonate.
This is the carbonate
Is the 3.
radical.
Okay,
Yeah.
okay.
And the
Just wanna
CO2,
understand that I don't
one, the
write down
carbon
wrong.
and 2 atoms of oxygen are gonna go off gas during the firing.
Right.
And you're gonna end up with copper oxide and cobalt oxide.
Okay, so single oxygen, single O is an oxide.
Well, it's not all the same,
Oh, okay,
because this is,
that's ferrous
Fe
oxide.
is for ferrous.
Yeah.
Latin is where all these come from. 2 atoms of iron, 3 atoms of oxygen. It's called red iron oxide.
Okay. All right, so there's
Fe,
no way
this
to,
is based on, remember last week? FeO,
yeah,
this is iron oxide.
right,
And this is black iron oxide.
right.
Okay, so now we have to
Okay.
figure out what percentage of these metal oxides are we using in this particular glaze. And with the
Okay,
process
so
is
we have-
exactly the same.
560.
You're going to divide by the batch of the glaze,
Oh, not by the.
not the total of the additives.
Oh, okay.
These are things that are added to a glaze. The glaze we're referencing had 16,000 grams. We have put 320 grams into 16,000.
Okay.
So now we have to do the same math, except we're gonna have a whole bunch of
Zeros.
dots and zeros here.
Yeah. Okay, so.
So you're not including the 560 grams, you're just rounding it off to 16,000
When
grams?
we did
No,
feldspar at 9,000 grams,
Yeah, no.
we divided it by 16,000, right?
Oh, yeah, yeah.
This 320 for rutile is how much rutile belongs in that glaze. The glaze part was 16,000 grams.
2,000, okay.
Okay, well, I came up with .02 for the first one,
Uh-huh.
Or 2%.
or 0.02. Okay. And then I
The
can't
second one
see
is
the-
.01. Third one is .005. Yes.
Okay. He's got it memorized.
Okay, everybody comfortable with the math side? And as we did before, we can move the 2 decimal point.
So 2%, 1%, and a
So-
half percent.
3%, 1%.
And
A way to read
.05.
that is 2%, 1%. And this is a place where it gets a little bit awkward in this system, is half of 1%.
Yeah.
And it's an easy sort of decimal fraction problem, so I'm prone to write 0.5%. Which is sort of breaking from the mathematical,
Usually just put 0.5%.
well, I don't
0.05.
disagree, because that
Oh,
means
oh.
the
It's the
same
same
thing.
No, it's 0.5%, not 0.5.
.05, yeah.
Oh, there was three.
No, it's
No,
point,
it's
no, it's
No,
point
0.5.
5%.
Yeah.
Yeah.
0.5%.
0.5%. Oh, I did 05.
Okay.
So these are the numbers that you write in the unity column opposite your additives.
Okay.
And I'll explain why I use that format in a moment after you write them in. Because for this glaze, 2% rutile, 1% copper carbonate, 0.5% cobalt carbonate. Mix that all together, put it in the kiln on your wear, on B-mix at cone 10, that's what you can expect.
So I can see that using these percentages, you can go to a batch size, any batch size you want.
Hold on a
But-
moment, yes?
okay. But I'm
Yeah.
wondering why you're using percents and not the fractions.
I'll tell you why
Okay.
in a moment. So everybody's got this. And the key element here is you don't add these up. They're just part of the glaze. They're added into 16,000.
That makes sense though.
Yeah.
So
Makes perfect
Because the
sense.
glaze itself is
I'm probably
16,000
getting ahead
grams.
here.
Right.
And they're just an additive. And so when we looked at the total number
here's
of
the one
grams
that
over
I'll
here,
build in.
there was 560 grams. Those were the
I'll build it
additives, but they were added to the 16,000 gram
Right.
base.
And
Yeah.
page 4,
It's all done for you.
Cheat sheet.
I don't wanna keep my sheet clean so I can,
now the reason
Copy it.
that I have moved from the decimal fraction that's in the column up here to written percentages here is to remind myself that whatever amount of this glaze that I make up,
this is
I
a
want 2%
percentage
of that total. So, a standard 5-gallon bucket in this studio, we mix water and 8,000 grams of glaze material.
Okay.
So, if you take the far right column and you write up there batch size 8,000 grams,
I got my pen holding the camera.
In the far column?
in the, I
The
usually
next
put 8,000
right,
over
the
there.
next right-hand corner
No,
or the far
I,
side?
since
Or
that's
all the way to the other side?
all the way to the other side, because that's as large a batch as we would typically mix in this studio.
Okay.
So you write in there 8,000 grams, and then the question is, how do you translate the Unity recipe that added up to 100 into 8,000?
Times it.
It's just a simple step. You take your batch size and divide it by 100.
Okay.
That's going to be 80. Then you multiply each of these individual ingredients by 80. And that's the number that goes under the batch, 8,000 gram batch.
So, okay, so that really gets back to my question. If we get back to these numbers.
Right.
Before we multiplied them by 100, if we just left them with their decimal points.
Then they're
we
going to add
could-
up to 1.
Then they add up to 1. and
So
then
you
could
divide
just-
1 into,
Then you could, no, you don't have to. Then you just multiply them by the batch size. And you get the
that,
same number.
you're
Is that right?
absolutely correct.
The batch size, times by 100 to equal 80?
You divide the batch size by 100,
Okay,
that equals 80.
okay,
You multiply each of the ingredients, feldspar 61.5 times 80,
okay, and then,
kaolin 20.4 times 80.
okay.
And that gives you your proportion.
Yeah.
That you're-
So then we're gonna take,
But since the reason we've
we take
made these
80,
in
right?
percentages is if we want
times it
some
by
standard that we're going to add up to, and in ceramics, 100
Yeah.
is the standard.
I see.
It's
Okay.
it's no
As
magic.
opposed,
Yeah.
it's just,
Instead of one.
it's convention as opposed
Yes.
to,
Yeah.
instead of adding up to 1,
61.5.
it adds
Yeah.
up to 100. I
Exactly.
gotcha, I gotcha.
But now, since you're doing grams,
Right,
weight measurement,
right.
so we use a scale then to do all this
That's
work.
we'll be doing that next week.
Okay,
Yep, that's correct.
So what'd you get on the numbers?
okay.
So like,
So,
you know the
51.5.
different size, you know those
49
tubs with the
point?
two robes on each side?
Right.
How many,
I'm going to guess those are 10-gallon containers, but I don't know that to
just
be true.
two batches of,
10, we use 5-gallon buckets in the
Right.
Glaze studio for convenience. The big ones take up a lot more floor space. So.
two or three, huh?
Come to date. So
Plus
then
the
it,
5
Now, I
gallon
wanna check.
bucket you
Okay.
can get a lid
Where do you-
for,
where do you put
whereas
that?
that
I mean,
rolled
I put
tub
the
doesn't have
8,000
a
Right,
lid.
well, that's the wrong place. The 8,000 should be in the batch size cell
Yeah.
up above.
Up
Plus
above.
they're
above,
curved,
yeah.
I think, too. Well, I
Oh,
didn't
up
know
above.
they aren't, but, yeah.
okay.
Up above
It's
the
just you
column.
want to be able to read across the.
So
in
I
each-
understand, I read it
Row.
correctly.
I
What happened to my
knew
pencil?
that's what he used.
So
Alright,
let
I got it.
me,
There you go.
Okay, so
All right.
8,000 or 80 times 61.5 equals what?
4920,
Green, okay, 80 times 20.4,
1632,
Something.
okay, 80 times 18.1.
1448.
Now, did you add that?
Yeah, it comes up to 8,000.
Okay. Because it's so easy to make a decimal error. And then you work on that decimal error and you make a glaze that's not the glaze you thought you were trying to make, and you wonder why, and you have no record of an error in the process because you didn't think there was an error.
Yeah, it was all in the math.
It's just like doing accounting, you've got columns that go
So
both
then you would,
ways, so.
you would take the 80 times 2.
Then,
Here he goes, here he goes.
down at the bottom,
Yeah.
this is a reminder that we want a percentage of the batch size.
Okay.
We want 2% of 8,000.
Okay.
Now, at that point, you convert that back to a
16 or
decimal
something
fraction,
like
point
that.
0.02 times
80.
8,000, and you're going to end up with 160.
160, okay.
Copper will be
go
80,
back to these.
cobalt will be 40.
Yeah.
Convenient because it's
Well,
half the
yeah.
size of where we started the
Obviously,
big
but
batch.
it, yeah, and
So
it's
the
not, that
funnel-
half isn't that big a deal,
160.
with the, when you're dealing in such a large figure, you know,
Yeah.
you don't,
These are not inherently difficult mathematic relationships, but there are ways to get confused, or if you're not familiar with doing this sort of work, it can be really problematic. So if you wanted, another batch size of 5,000, or you were said, I want to test this glaze with some different colorants, it would be really convenient to have a 1,000-gram batch to work with. So you can have whatever sizes.
So how would you, you measure, okay, I can
Whoa,
figure.
whoa, I'm sorry, I'm looking at what you've done there.
No,
Yeah.
not right.
Well, those are the same, that's the same information you've got over there in the 100 column.
As opposed to
Yeah.
percentages.
Okay, and what you want in that,
That's okay.
in that
It's- it
vertical
mathematically
column
is the same.
is,
Is it times 80?
it's times 8,000. Point made.
So it would be
Here.
16, so you
Point
go,
It's
Times
a 0,
divided
0 point, point 0
Pardon me?
Times
8,000.
8,000.
Because
Divided
you've got
by-
8,000 as the batch size.
Don't look up there.
I know, okay.
Point zero
Times
So,
two
8,000.
so here, you've got 8,000, you divided
Equals
that by
160.
100 to get
160.
80.
Oh,
So
it-
that
I was
now
way
is our
off.
proportion, our multiplier.
Okay, that's right.
Times each one of
160.
these.
Divided by-
so
You
these,
said you
up here for the ingredients, the
Not
three
16.
ingredients of the glaze,
Multiplied
that's
by
pretty
100,
much
dividing this by
the
100.
basic glaze
And then
for
Well-
most high fire glazes.
No, that's unusually simple.
because it's one.
Oh,
5 or 6 ingredients are far more normal.
oh, okay.
And then the cobalt is
Then we get into a little more
0.5.
So half of 80
to
is
get to our
40.
100%, okay.
0.005 times 8,000, right? Right?
What would you add to that
And then that
to
would
make,
equal up to 80.
Well, that doesn't have any iron in it. What if you wanted to
Oh,
look for a warm use of that color?
4,000.
Maybe iron and rutile by themselves, rather no cobalt, no copper.
I think it was, it's me, because it doesn't add up, so let me
so the
do this
iron
again.
would go in the ingredients, but not the additives?
No, it would be, the colorants are always additives.
And the-
Yeah, it
Oh,
should be
okay, I'm
20.
talking
I
about
think I
the
just
three,
wrote it
your
down.
three ingredients up here, not your additives. Thought-
Yeah, 'cause
Right,
it's-
so you don't have to change anything. We already know that glaze melts at cone 10.
Right, so what I'm saying
Yep.
is, that's the basic
That's correct.
formula for, and then you go from there to add all your additives.
Yes, that is correct.
Okay, so, okay, I got that, okay.
And that adds up to 8,000.
Everything else is added.
Okay, good, all right.
Well,
So
now, wait a minute, lighting was
now-
on the same page as something else.
You are a wonderful group to work with. I am delighted.
We're not the cats this
Wait
year.
a minute, where did the lighting go?
That's all
So,
I'm gonna
No,
say.
you're not the herding cats group, that's
Yeah.
right.
so is this, for the additives, we
Monitoring.
want 2% of 8,000?
Correct.
Okay, got it, all right.
Okay, so that's the feldspar and the lighting, and then
This is very interesting.
So that's just gonna be 80. And then this is gonna be.
so you would only add talc or dome or any of these things
Those
here if
fluxes.
you wanted those particular contributions that they make.
Correct.
Okay.
But you don't just add them because that
No, they gotta
flows
be in a
off.
percentage or something. I mean, they gotta be.
Well, you are now
formula.
at that point in the glaze process where everything you do from here out is original research.
Under pressure.
Little queen.
Yeah, heck, why not?
So for the additives, I got, just clarifying with everybody, 160 grams, 80 grams, and 40 grams.
Correct.
Correct.
Making sure that we're all on the same page here.
Thank you. All right, for my explanation sheet.
You're welcome. You can't do something like this one time and think you've got it.
I know,
It's
that's
good.
for sure.
You can't?
Unless you have photographic memory.
We'll find out because next week I'll say, okay, here's a recipe.
Oh,
Make the glaze.
prepared.
No, I think he said just that this particular recipe that we had was written for 16,000 grams.
And so you told me, sorry, a 5-gallon bucket is normally
8,000 grams.
8,000. That's what we're doing here, okay.
8,000, yeah.
Five
So,
gallon.
because that's the
That's
maximum
all
size that we could,
This is the studio starting point. This is a gift. And the way you receive this gift is you read the first page before you go any further.
takes me back to my youth here.
Oh, goodness, this is a book. Bread book. Okay. I used to make bread.
I read fast, I don't do math fast. Give me a break.
Everyone's gonna wanna use this thing
Yeah.
later.
So, yeah, just wait a moment.
I'll wait.
And it's always good and nice to share. That's what you learn a lot more creation by sharing, I think.
This process is nothing that we do alone. There are occasionally ceramic artists who have been working for years and years, and they become very protective of the results of their research, and that's understandable. All the rest of us are riding on each other's shoulders that go back for thousands of years, and
Praying that it comes out decently.
accepting the fact that it doesn't always work well. So we will begin next week, sitting down with the pages that I just shared with you. I will ask you, first of all, what's still sticking in your minds from this week's discussion of materials. And then we'll go on into mixing glaze. Once we mix glazes, then it's time for you to start to apply glazes to your test tiles and get them fired. On a general pattern of recognition, we load the high fire kilns, the Royal Mike and me, load the high fire kilns on Tuesdays, fire them on Wednesdays, they come out on Fridays. So when you're doing these test tiles, any of you who want to do them directly next week will get some of them into the kiln on Tuesday of next week, right after class, and we'll make sure they get into the kiln. Otherwise, it'll be offset till the next. Most of you will be glazing on Thursday.
Not this yet.
How many,
It's time. It's time to get them made and get them bisque
All they're
fired.
made, they're just taking a long time to dry.
Yeah, bring them in.
That
put them out in the sun.
requires special care.
They should have dried, but, I mean,
So,
Yeah, I figured. I made mine over our last week. I was assuming they were
Dry
by
enough to
today.
bisque?
Mine are
Yeah.
in, mine
Are they
are in a
bisques?
garage.
No, I just
Yeah.
put them, I just
Doing it at
put
home.
them for biscuing
are,
today.
are there any questions about anything else from today?
now, okay, from today, okay.
Well, or in general, just,
No, I'll wait till
No, I
next.
need
Just
deep
wait for the
thought and
surprise.
repetition.
Okay.
you're welcome.
Yeah.
The hole punch is now available.
All right.
Yeah.
Okay. Lovely day. I do appreciate you. I forgot to tell you, this is,
It's a good lunch.
Silica,
Yeah, let me,
glass.
no, it's his.
so it's one of the materials we need to be
For
most
a few
cautious
minutes,
with,
but you can look at it.
because this is so finely pulverized
Yeah.
that it will pass right through the mucus-covered hairs in our nose, settles in the bursa sacs in the lungs. The bursa sacs are where oxygen is exchanged with the blood, and it's little broken glass, and it will make a small incision in the bursa sac that will then heal as a scar tissue, and that scar tissue is no longer as elastic as the rest of the tissue, and if you do that for 40 years without
Can't breathe.
thoughtfulness,
Yourself.
it's called silicosis.